In this class, we will discuss one more problem on equilibrium of bodies. Of course, it is a typical different type of problem wherein he has given three cylinders, A, B, C, three cylinders of different diameter and different weights, kept in a ditch. This is a trench or a ditch with width 450 mm, and he has given the diameters of the cylinders as for this cylinder A, diameter is 200 mm, for B it is 300 mm, bigger one, C medium one, that is 250 mm, and weights of cylinders are also different. Cylinder A weighs 75 Newton, B weighs 200 Newton, C weighs 100 Newton. He has asked the reactions at the contact points, assuming smooth contact surfaces. Smooth contact surface means you will be having only one reaction, as I already told, which will be normal to the contact surface. So here, if you see the number of contact points, so you can see here there is one contact point here between the sphere C, cylinder C and the wall. Then second contact point I am going to take between the cylinders B and C. Third contact point between the cylinder B and this wall. Fourth one between cylinders A and B. Fifth one between cylinder A and the wall. Sixth one between cylinder A and the floor. So there are 6 contact points here. So therefore, you will be having 6 reactions. So 6 contact points. At each point, you will be having 6 1 reaction. Therefore, you will be having 6 reactions: R1, R2, R3, R4, R5, R6. And how they will appear, how they are going to develop, you can just see here. So first cylinder is here, second cylinder is here, third cylinder is here. Now I have shown you I have given you the contact points. The first contact point is 1. So these are the spheres A, B, C. So the first contact point is 1 here. So reaction here will be normal to that contact surface. This is 90 degrees. Okay. Second contact point is here. So as I already told in the earlier problem, when two cylinders or spheres they meet at a common point, reactions will develop like this. They are collinear, equal and opposite, and they pass through the point of contact. Who is the point of contact? So when you are going to write like this is also R2, this is also R2, because the contact point is 2. But for the spheres, for the cylinder C, this is the reaction. For cylinder B, this is the reaction. So both are equal, collinear and opposite. Next, third point I have taken here. So here the reaction will be normal to this contact surface. R3 will be like this. Then fourth contact point is here, and here also the reactions will develop like this. So please note that the reactions, the line of action of the reactions, they pass through the center of gravity of the cylinders as well as the point of contact. So this is the point of contact 4, and the reactions will develop like this. So this is R4, this is also R4. So this R4 is for this cylinder, this R4 is for this cylinder. Okay. Then coming to point 5, this is point 5, normal to the surface thing, this is R5. So this angle is 90 degrees. Then coming to point 6, this is point 6, normal to this is R6. Now you can see these are the reactions that are going to develop: R1, R2, R3, R4, R5. So R4 and R2, there will be 2 reactions exerted on each body. They will be equal, opposite and collinear. Now there are 6 unknowns here. When since there are 6 unknowns, we need 6 equations to solve the problem. So 6 equations, 6 equilibrium equations. So for each sphere for each cylinder, we will be having 2 equations. Sigma f is 0, sigma f is 0. So 2 into 3. So totally you will be having 2 equilibrium equations for each cylinder into number of cylinders is 3. So totally you will be having 6 equations. So you can solve for the 6 unknowns. Number of equations will be equal to number of unknowns. Now next question is which cylinder we have to consider first. As I already told, since you can solve only 2 unknowns by taking the ball diagram of one sphere or cylinder, so only 2 unknowns should be there. So for example, if I take this A, R5, R6 and R4, 3 unknowns are there, we cannot solve. If I take this B, R3 is there, R4 is there, R2 is there, we cannot solve. If I take C, only R1 and R2 are there, so we can solve. So first, let us consider the free body diagram of cylinder C. So depending on the number of unknowns, we have to consider. So number of unknowns should not exceed 2. So here, so this cylinder C has got only 2 unknowns. So this is C here. Weight of this C we also have to take when you are writing the free body diagram. Weight of C is 100 Newton, which acts vertically downwards. That we have to write down. Don't forget that. Then you have R1 reaction acting like this. R1 is perpendicular to this contact surface. So R1 passes through this. The C is the, let us take C as the center of gravity. So for this cylinder C, it passes through this. Then you have R2. This one we have to do. These two. R2 we have to take this, and this also will pass through this C. So all these 3 forces, they constitute a concurrent force system. Either you can solve this by Lami's theorem or by using equilibrium equation. Let us use equilibrium equation. Now only thing is we need here to find this angle. So I need this angle now. Let me take this angle as theta. So we have to find out that angle. Once you know that angle, then you can resolve this R2 and you can write down the equilibrium equation. Now let me take this triangle and we find the angle now. So be careful here. So this is the triangle. So please note that this is C, this is B, this is 90 degrees. Now I need this angle. This is theta. So to find this theta 1, I need 2 dimensions. So one dimension you can see here. So this CB is nothing but this radius plus this radius. So radius of C plus radius of B. So radius of C will be 125 because we have given diameter. Half of this we have to take. So 125 plus radius of B is half of this is 150. So 125 plus 150. So this will be 125 plus 150, which is 275 mm. So the length of BC is 275 mm. Then one more dimension I need. Either I need this vertical or I need this horizontal. I think it is better to go for horizontal because here you see this width is known. This is 450 mm. Width of the ditch or trench is known. Now if I draw a perpendicular here from C here perpendicular, now I can always find out this distance. So this if I take this as D, so this as D, so I can find out this dB. So dB will be equal to, we can see this total width, that is 450. So dB or VD is equal to total width of the trench is 450. This 450 minus this radius minus this radius. That means minus, we can take radius of this as radius of C is 125 and this radius of this B will be 150. So 450 minus 125 plus 150. That means it is 450 minus 275, which is 175. 175. So this distance now becomes 175. So by knowing two dimensions of the triangle, you can calculate the angle now. So which ratio I have to take? So this is theta 1. If I take cos ratio, cos theta 1 will be adjacent side is BD divided by hypotenuse is that is BC. So that is 175 divided by 275. So 175 divided by 275 cos theta 1. Therefore, theta 1 is cos inverse of. So I will write theta 1 is cos inverse of, from the calculator, 175 divided by 275, which is nothing but 50.48 degrees. 50.48 degrees. So angle is known. So this angle you can use here. So now this what is that? R2 is making an angle of 50.48 degrees with the horizontal. So if you draw like this, so this angle will be 50.48 degrees. Please note that is very important. So once you get it, of course, I have calculated this angle. So this and this they are equal. This is theta 1. Same theta 1 will be there here. Vertically opposite angles. Now you can resolve the force into components. The horizontal component of this R2 will be like this. Vertical component is like this. So be careful. So this is in the second quadrant. The x component is negative, y component is positive. So this is R2 cos 50.48 degrees. This is R2 sin 50.48 degrees. Now you can use the equations of equilibrium. These two you need not resolve because one is horizontal and one is vertical. Now I will apply the two equations of equilibrium. Sigma Fx is equal to 0. Rotating force is acting towards right positive. R1 is positive. Okay, this is negative minus R2 cos 50.48 degrees. That's all. So this doesn't have any horizontal component, is equal to 0. You can treat it as equation 1. Now second equilibrium equation, sigma Fy is equal to 0, upward positive, downward negative. So this is downward minus 100, minus 100, 100, where this is upwards, plus R2 sin 50.48 degrees is equal to 0. So from this you can get R2. R2 is equal to 100 divided by sin 50.48 degrees. So 100 divided by, using calculator, 100 divided by sin 50.48 is equal to 129.63. 129.63 Newton, because the weight of the cylinder is given in Newton, so reaction also will be in Newtons. 129.63 Newton. Substitute this in 1. Substituting in 1, you get the value of R1. So R1 is equal to R2 cos 50.48 degrees. So R2 is 129.63 into cos 50.48 degrees. So if I simplify that, so this into cos 50.48 is equal to 82.49. 82.49 newtons. That is the reaction R1. So reaction at 1, this reaction is 82.49. R2, this reaction is 129.63. Both are positive. That means the assumed direction of the reaction is correct. So this is the first free body diagram. So using the first free body diagram, that is the free body diagram of the cylinder C, we got two values of the reactions R1 and R2. So R1 we got 82.49 Newton and R2 129.63. Please check the values. So you have to do it yourself and then check the answer, check the values. Because if I have done some mistake, it will be corrected. Then now, once we got these two, now we have to go to the second free body diagram. Second free body diagram is for the cylinder B. When you take the cylinder B, R2 is there, R3 is there, R4 is there, out of which R2 is already we have found out, it is known. Only unknowns will be R3 and R4. Now let us write the free body diagram of cylinder B. Free body diagram of cylinder B. On similar lines, you can find out the unknown reactions R3 and R4. Now let me write the free body diagram. So cylinder B is here like this. This is cylinder B. So R2 is acting like this. For this cylinder B, R2 will be acting like this. It passes through this B Of course, R2 value we got now. R2 value is 129.63 Newton. That's what we have found out. You can write it. Then R4 will be like this. R4 will be like this. It also passes through this B, but we don't know what is the angle with which that R4 is making. So this rectangle, I will take it as theta 2. Let us find out theta 2. Then R3 will be like this. It is horizontal. You can see here. In addition to that, we have the weight of the cylinder given as 200 Newton. Weight is 200 Newton. So this is the free body diagram of the cylinder B. Cylinder B. Now here only R3 and R4 they are unknowns. Before resolving the forces, we will calculate that theta 2 angle. So if I take that theta 2, so you see once again we have to consider a triangle like this, right angle triangle, 90 degrees. This is B, this is A. You can see here this triangle. This triangle we have to take now. If you draw a right angle triangle like this, I will take this as E. If I take that as E, this becomes E. Now AB. What is the length of AB? This radius plus this radius. So radius of A is 200 by 2 is 100. Radius of B is 300 divided by 2 is 150. 100 plus 150, it is 250. So 100 plus 150, 250 mm. So that is the length of AB. Then I need this AE value. Once again, this AE value is nothing but this total length is 450. In that we have to deduct this radius and this radius. Okay, radius of this cylinder is half of this, that is 100. Radius of this will be 150. So 450 minus you will take 100 plus 150. So 450 minus 250, which is 200. So this length is 200 mm. Now once you know two dimensions, I have taken this as theta 2. So you can once again here also cos theta 2 ratio we have to take. Cos theta 2 is 200 by 250, which is 0.8. So therefore theta 2 is equal to cos inverse of 0.8. So from the calculator, we will get cos inverse of 0.8 as 36.87 degrees. 36.87 degrees. Now this angle is now 36.87 degrees. Now you can resolve this R4 into two components. Horizontal will be like this, vertical will be like this. So you have to resolve in such a way that the arrows of the component forces should meet the arrow of the force. So this is R4. So since this is the angle with respect to horizontal, cos 36.87. This is R4 sin 36.87. Now we will write the equilibrium equations for this. Sigma fx is equal to 0 towards right positive, left negative. This is positive R4 cos 36.87 degrees positive. Then this R2 also I have to resolve. Please note, I have to resolve this R2 also. If I resolve it will be like this. You know this is theta 1. So the value of theta 1 we got the value of theta 1, how much you got? So it is theta 1 is this is 125, this is 150, 275. 450 minus 275, that is 175 we got. So 175 multiplied by, say okay, hypotenuse is this is 275. Hypotenuse is 150 plus 125, 275. So cos inverse of degrees. Okay, 50.48. Correct? 50.48. This is 275. 275 divided 175 come 175 divided by 275. Yeah, 50.48 degrees. So we have attained, we have calculated 50.48 degrees. So if you resolve that, this horizontal component will be R2 50.48. This will be R2 sin 50.48. This is R2 cos 50.48. Okay, anyway, R2 value you know. So this R2 value is 129.63 and it is acting towards side. Therefore, 129.63 cos 50.48 degrees. That is the horizontal component of this. Then we have to take this R3 also is acting in the opposite direction towards left minus R3. Then this weight won't come into picture because it is acting vertically down. This is equal to 0. So there are two equations, there are two unknowns here we cannot solve. So one more equation we have to get. So this is equation 3. So then I will take sigma Fy is equal to 0, upward forces positive, downward negative. So this is negative minus R2 sin R2 is okay. You can substitute the value of R2 minus 129.63 sin 50.48 degrees. This is upwards plus R4 sin 36.87. It is R4. Then you have this R3 does not have any vertical component minus 200 because when it is acting vertically downwards is equal to 0. This is equation 4. So now you can see from this equation you can get the value of R4. So R4 is equal to, if you simplify this, R4 is equal to, bring these to the side, 129.63 sin 50.48 degrees plus 200 all divided by sin 36.87 degrees. So this is the R4 value. So let us calculate it. 129.63 into sin 50.48, then plus 200 divided by sin 36.87 is equal to 499.9, that is 500 Newton. So the value of R4 is 500 Newton. From that we can calculate R3 by substituting in equation that is equation 3. So substituting in equation 3 we can compute the value of R3. Okay, so I will write here substituting in equation 3. Substituting in 3, R3 is equal to R4 cos 36.87 degrees plus 129.63 into cos 50.48 degrees. So substitute for R4 as 500 Newton. So 500 cos 36.87 plus 129.63 into cos 50.48. So if you simplify this, so 500 into cos 36.87 plus 129.63 into cos 50.48. So the answer is 482.49. 482.49 newtons. So that is the reaction R3, 482.49. Now lastly, we need two more reactions, that is R5 and R6, which are exactly on the cylinder A. So to find that, we need to consider the free body diagram of cylinder A last. So cylinder A we have to consider now free body diagram of cylinder A. So if I write the free body diagram of cylinder A, it is like this. This is A. Weight of the cylinder is 75 Newton. So I will take 75 Newton vertically downwards weight. Then we have R5 is the reaction horizontal, and the reaction passes through this A. Then R6 is vertical. So this that will be here like this. So this is R5. Sorry, R6. Sir. Then you have this R2. So R2 will be acting like this. So which an angle? So this angle already we have computed that angle. That angle is R2 and not R2, sorry, it is R4. R4. So the theta 2. So the theta 2 angle we have quoted as 36.87 degrees. So we have computed that also. So these are the weight. Then two reactions. R4 we have found out already 500 Newton. For this cylinder, R4 will be acting like this. Now this is the diagram, free body diagram of cylinder A. So only we have to resolve this R4. So if you resolve that, horizontal will be like this, vertical will be like this. 500 cos 36.87. This is 500 sin 36.87. Now let us write the equations. Sigma f0 and sigma f0 for this cylinder A. So sigma f0, if I write sigma f0, first equation, sigma f is equal to 0 towards right positive, left negative. R5 is positive and this is negative. So R5 minus 500 cos 36.87 degree is equal to 0. So from this R5 you can get it as 500 into cos 36.87. So which comes out to be 500 into cos 36.87, which is 399.99, which is 400. So 400 Newton. So R5 is 400 Newton. Then lastly we can get sigma Fi is equal to 0 if you apply upward positive, downward negative. So here weight is 75 Newton acting vertically downward, but reaction R6 is upwards plus R6. Then vertical component of this is acting downwards, so minus 500 sin 36.87 degrees is equal to 0. So here, if you simplify this, you will get R6. R6 is equal to 75 plus 500 sin 36.87 degrees, which comes out to be 75 plus 500 into sin 36.87 is equal to 375.00. So 375 Newton. That is the reaction at 6, contact point 6. So like this, we can find out the reactions at the contact points. The condition is number of unknown reactions should be equal to number of equilibrium equation that should be available to analyze the problem. So once you have sufficient number of equilibrium equations, then you can always solve the equations to get the unknown reactions. Now this is a typical type of problem where it has given different radius, different weights, and of course these angles are unknown. So we need to compute the angles, theta 1, theta 2, all those things by using the trigonometry of the right angle triangles. Then we have to resolve the forces, and you have to choose in such a way that the number of unknowns available for any free body diagram should not exceed 2. So because we have only 2 equilibrium equations to solve, so you have sigma f0, sigma f0. So finally we can solve by taking the free body diagram of each sphere or cylinder separately, and then later on applying the equilibrium equations and solving them. So first thing we have to see here is number of unknown should not exceed 2. So that free body diagram of the object you have to take first.